When United Airlines announced a $1 billion order for 200 Archer eVTOL aircraft in February 2021, followed by American Airlines' $1 billion commitment to vertical aerospace, the aviation industry didn't just take notice, it fundamentally shifted its entire future strategy overnight. But here's what shocked even seasoned aviation analysts. Major airlines aren't just experimenting with electric aviation anymore, they're betting their next-generation route networks on it. And the numbers suggest they might be right to do so. Today, we're diving deep into why electric and eVTOL aircraft could fundamentally reshape commercial aviation by 2045, and why traditional jet manufacturers are scrambling to catch up to what industry insiders are calling the biggest disruption since the jet age. The implications go far beyond just cleaner skies. We're talking about a complete transformation of how passengers move through urban environments, how airlines structure their operations, and how airports themselves function. The question isn't whether electric aviation will arrive, it's whether traditional aviation is prepared for what's coming. To understand why electric aviation represents such a seismic shift, we need to examine where the industry has been. Commercial aviation has undergone three major technological revolutions: the transition from propellers to jets in the 1950s, the wide-body era that began with the Boeing 747 in 1970, and the efficiency revolution led by the Boeing 787 and Airbus A350 in the 2000s. Each revolution fundamentally changed the economics of flying. Jets cut travel times in half. Wide-bodies made international travel accessible to millions. The efficiency revolution reduced operating costs per seat mile by 15 to 20%. But here's what makes electric aviation different. It's not just about incremental improvement, it's about creating entirely new markets. The numbers paint a compelling picture. Urban air mobility, the market eVTOL aircraft are designed to serve, is projected to reach $1 trillion globally by 2040, according to Morgan Stanley research. That's larger than the current commercial aviation market. Meanwhile, traditional aviation faces mounting pressure. Airlines spent $181 billion on fuel in 2019, roughly 24% of total operating expenses. Carbon emissions regulations are tightening globally, with the EU implementing its Fit for 55 package and CORSIA requirements creating real financial penalties for carbon-intensive operations. The convergence is clear. Rising operational costs, environmental pressure, and urban congestion are creating the perfect conditions for electric aviation to emerge as more than just an alternative, as a necessity. The technology timeline has accelerated dramatically. Battery energy density has improved by 5% annually over the past decade, while costs have fallen 89% since 2010. Electric motors now achieve 95% efficiency compared to 35% for turbine engines. When you factor in the simplicity of electric powertrains, 20 moving parts versus 2,000 in a turbine engine, the maintenance cost advantages become overwhelming. Here's the crucial insight. We're approaching the inflection point where electric aircraft don't just compete on environmental benefits, they compete on pure economics. Let's examine what electric aircraft can actually do today versus where they're headed. Current eVTOL designs like the Joby S4 offer 150-mile range with 5 passengers, cruising at 175 miles per hour. That might seem limited compared to a Boeing 737's 3,500-mile range, but it's perfect for the 80% of flights that are under 500 miles. The Aviation Alice, designed for regional routes, demonstrates 500-mile range with 9 passengers, directly competing with turboprops like the King Air or PC-12. More significantly, its operating costs are projected at 60 cents per seat mile compared to $2.10 for comparable turboprops. Battery technology is the critical constraint, but the trajectory is clear. Current lithium-ion systems deliver 250 to 300 watt-hours per kilogram. Solid-state batteries, entering production by 2027, promise 500 watt-hours per kilogram. Lithium-sulfur systems under development could reach 700 watt-hours by 2030. Here's how this translates. Today's 150-mile eVTOL range becomes 300 miles by 2027 and 450 miles by 2030. Suddenly, you're covering routes like New York to Boston or Los Angeles to San Francisco, core airline markets. The certification landscape has evolved rapidly. The FAA created new Part 23 regulations specifically for electric aircraft, streamlining the approval process. EASA has certified electric aircraft like the Pipistrel Velis Electro, establishing the regulatory framework. Manufacturing scale is accelerating. Joby Aviation has completed over 1,000 test flights and aims for commercial service by 2024. Lilium has logged 100,000 flight test hours across its technology demonstrators. Archer plans to begin production at its Georgia facility in 2024, with initial capacity for 650 aircraft annually. The supply chain is maturing. Companies like Safran, Honeywell, and Collins Aerospace, traditional aviation suppliers, are developing electric propulsion systems, flight controls, and avionics specifically for electric aircraft. This isn't startup technology anymore. It's becoming integrated into the established aerospace industrial base. The infrastructure transformation required is both massive and achievable. eVTOL operations need vertiports, essentially simplified helipads with charging infrastructure. Initial deployments will use existing helicopter infrastructure, but dedicated networks are planned. Lilium has partnered with Ferrovial to develop vertiport networks across Florida and the Northeast. Urban Air has agreements for vertiports in multiple European cities. The infrastructure investment is measured in millions per location, not billions like traditional airports. Charging infrastructure scales efficiently. Fast charging systems can replenish eVTOL batteries to 80% capacity in 10 to 15 minutes. Ground power requirements are comparable to existing airport electrical systems, making integration with existing infrastructure feasible. Major airlines are restructuring their entire approach to short-haul routes. United's eVTOL investment isn't just about new services, it's about replacing expensive turboprop routes with lower-cost electric alternatives. American Airlines sees eVTOL as solving the last-mile problem, connecting passengers from airports to city centers more efficiently than ground transportation. The hub-and-spoke model faces disruption. If eVTOL aircraft can provide 150 to 300-mile range economically, the need for regional jet connections diminishes. Passengers could fly direct from smaller cities to major hubs, or even bypass hubs entirely for certain routes. European airlines are moving even more aggressively. SAS has committed to electric aircraft for Scandinavian domestic routes. Air France-KLM is exploring eVTOL for airport connections. The regulatory environment in Europe, with stronger carbon pricing and emission restrictions, accelerates adoption timelines. Traditional aerospace manufacturers are adapting their strategies. Boeing has invested in Wisk Aero and is developing autonomous eVTOL technology. Airbus leads the City Airbus project and has demonstrated full-scale eVTOL flights. These aren't side projects, they're core strategic initiatives. The competitive landscape is reshaping. New entrants like Joby, Lilium, and Archer aren't just competing with each other, they're positioning to capture market share from Boeing and Airbus in specific segments. Regional aircraft manufacturers like ATR and Embraer face the most immediate competitive pressure. Supply chain implications extend throughout the industry. Electric propulsion requires different materials, manufacturing processes, and supply relationships. Companies investing in electric aviation capabilities position themselves for growth markets, while those focused solely on traditional propulsion risk obsolescence in key segments. Airports are beginning substantial infrastructure planning. Dallas-Fort Worth Airport has committed to eVTOL operations by 2025. Los Angeles International is developing vertiport capabilities for the 2028 Olympics. These aren't experimental programs, they're core infrastructure investments. The economics favor airports significantly. eVTOL operations generate landing fees, parking revenue, and passenger facility charges without requiring runway slots. A single vertiport can handle 200-plus operations daily, generating substantial incremental revenue. Air traffic control systems require upgrades to handle increased urban aviation traffic. The FAA's UTM, or Unmanned Traffic Management System development, accelerates to accommodate autonomous and piloted eVTOL operations in urban environments. Based on current certification timelines and manufacturing capacity, commercial eVTOL operations will begin in 2024-2025 in limited markets. By 2030, expect regular service in major urban corridors with 10,000-plus aircraft in operation globally. The 2035-2040 timeframe represents the inflection point. Battery technology improvements enable 400-plus mile range, making electric aircraft competitive for the majority of domestic routes under 500 miles. Airlines begin retiring older turboprops and small jets in favor of electric alternatives. By 2045, electric and eVTOL aircraft could represent 30 to 40% of aircraft operations under 500 miles, fundamentally reshaping regional aviation economics and urban transportation. The investment required is substantial but achievable. Total market investment in electric aviation exceeded $7 billion in 2022, with major aerospace companies, airlines, and financial institutions committing capital. This level of investment indicates confidence that electric aviation represents genuine market transformation, not merely technological experimentation. For passengers, electric aviation means more frequent flights, lower costs for short routes, and significantly reduced travel times for urban journeys currently served by ground transportation. The passenger experience transforms from airport-centric to destination-centric transportation. Electric and eVTOL aircraft won't replace all commercial aviation by 2045, but they will dominate specific market segments that represent significant portions of current airline operations. The question for the aviation industry isn't whether to adapt to electric aviation, it's how quickly they can position themselves for the transition. The airlines, manufacturers, and airports investing in electric aviation capabilities today are positioning themselves for the transportation infrastructure of 2045. Those waiting for proven technology may find themselves competing for shrinking market segments with increasingly obsolete assets. This transformation is happening faster than most industry observers expected just 5 years ago. If you're following aviation industry developments, subscribe to stay updated on how electric aviation continues reshaping commercial flight operations. The next revolution in aviation isn't coming, it's already here.